CVA is credit valuation adjustment, which measures the expected loss on an instrument due to counterparty or issuer default. The methodology employed by OTC backtesting and risk is completely consistent across all instrument types and easily extended to handle multiple trades with the same counterparty under a netting agreement. It is simple to understand and use and is based on actual historical price and rate movements, which can be amplified to test the calculation under more stressful conditions of higher than historical volatility. The actual calculation is based on a simulation of the instrument value at many points in the future over many simulation paths. It uses the same calculation as multi-period VAR, which generates many paths of simulated prices for the instrument over many points in the future. The expected positive value of the instrument in the future is calculated at each time period by averaging all the positive prices in that period. This average is multiplied by the probability of default and the loss rate, giving CVA. The value should be adjusted downward by this amount. The simulated prices are generated using the same algorithm as described for multi-period VAR, and many of the inputs are the same. The historical time window is specified. The user also specifies how far out to look and with what frequency. It also lets you select the number of simulation paths to run, the default probability, and recovery rate. Overlap indicates if only period start and end points are used from the historical time window, i.e. only January 15th, April 15th, etc. for quarterly. Or any points may be used. The change from Jan 15 to April 15 is one possibility, and Jan 16 to April 16 is another, etc. Then, a volatility factor can be selected, which takes the historical shifts and either makes them larger or smaller than the actual data. Entering 1.0 leaves them unchanged, while 1.1 makes them 10% larger and 0.9 makes them 10% smaller. Finally, Interrate Midpoint allows you to control the interest rate process. In the app, interest rate shifts can be a blend of normal and log normal shifts. Low rates are mostly multiplicative shifts, and high rates are mostly additive shifts. This mostly keeps rates from going negative or becoming too high. This input tells the app that rates above this level lead to purely additive shifts, and rates half this level lead to shifts that are half additive and half multiplicative. You also specify whether you are long or short the instrument, which determines which side of the distribution has positive values in the future. The output shows each simulation path as well as the average of the paths. It also shows the actual CVA as a price. The instrument mark-to-market value should be adjusted downward by this amount. Now that you've seen all the features of OTC backtesting and risk, it's time to actually play with it yourself and see how easy it is to use and how powerful the analytics can be.